down in more plain language, I guess, what we're doing here. We're trying to find the maximum value of this expression, max abbreviated, okay, in terms of A and B. And A and B are just real numbers. They could be complex numbers, I guess, if you wanted, in terms of A and B. A comma B and A comma B real numbers for this problem. But again, the same thing would hold for complex numbers because Cauchy Schwarz holds for complex numbers. I'll go ahead and put member of the reals here. Okay. Now, y'all, here's the Cauchy Schwarz for two componented vectors written down right here. I've heard it put the dot product squared is less than or equal to the product of the magnitude squares of the vectors. Now here, in this case, the vectors would be two component, but this holds for however many components you want. Now, there's an understood 1 right here, okay, is a coefficient of x. I'll try to fit it in there. That's a 1 right there, okay? And it's sometimes good if you're just getting used to this stuff to see it. That's the same as this 1 right here. This 1 and this 1 are the very same object, and it's just an immediate plug-in to the inequality, the Cauchy Schwarz inequality. Okay, and the rest of this is very straightforward. Let's see here. Anything else? Okay, like if you square this, this would be just x. So this part right here inside the parentheses, after you square it, would just be x. And then you would have plus b minus x after you square that part. Okay, plus b minus x. And of course you can see that's exactly where this b came from. Okay, the b right here. All right, now the rest of this, notice that the statement is in the squared form. You can state it in the square root form. I stated it in the squared form. But if you take the square roots of both sides, that is, if you take the square root of this object, you get the expression we are interested in. And then if you take the square root of this object, you get this. Okay, and so as far as what we set out to do, we've completed what we set out to do. This is a function. This is some function of A and B, right? The maximum value, and it's not surprising this is true, of course, but I just like writing it this way. It is a function of the two parameters, if you want to call them that were present in the original problem. I don't even know where the word parameter came from. It doesn't seem like it makes any sense why they call it that, but I guess it means you can vary them and see what happens. Now, so we would be done right now. With this would be what we were looking for as far as the problem goes. But let's do a concrete example. Again, we've satisfied what the problem asks us to do, but it's nice to just see it live. So here I just chose a equals 7, b equals 2/5 arbitrarily, and you guys can just verify. I substituted everything back into here, right? And when you go through the arithmetic, you'll get. You can see this would be 50. 49 plus 1 is 50. 50 divided by 5 is 10. 10 times 2 is the 20 you see in the square root. And that's approximately 4.47 decimal. Okay, and so what I did here is I used some software to graph this for y'all, and for me too. All right, now you can see the 4.47 really looks believable down here, right? If you take a look, that sure looks like a 4.47 to me somewhere in there, right? And you could find that value of x if you wanted to. I didn't do that. Okay, now just to make sure you believe this, notice that if x were 0, and remember this is the y-axis, this is just the y-axis right here, right? That's the y-axis, but another name for the y-axis is just x equal to 0, right? X equal to 0 anywhere, that's what you tell your algebra students, right? Another name for the y-axis is x equals 0, so you set x equals 0 to find the y-intercept. And so the y-intercept is somewhere down in there, and let's see what we get right here. If x is 0, you would get y, from this guy right here, let's just go straight above it, you would get y. Okay, this part's 0, so you would get y is equal to 7 times 2/5, square root of 2/5. Whoops, let me erase that, folks. I wanted that to be a 2. Okay, so that would be a 2/5 right there. Now, y'all, if you take the 7 inside there, it would be squared, right? It would be squared. So this is equal to 7 squared is 49, and 2 times 49 is 98. And so we would end up with the square root of 98/5. Y'all, but notice that 98/5 is definitely less than 20, right? 100/5 would be 20. So you see, as you would expect, this is less than the square root of 20, right? Pretty cool if you ask me to actually see it. Again, 20 is 100/5, right? 20 is the same as 100/5. Like that. And so that's, this value right here is would be this point right here, okay, that I'm trying to highlight, okay, right there. That would correspond to this 98, square root of 98/5. And of course, this point wherever it's located, and again, that would be something else I could have done for you, okay. That y coordinate is the square root of 20, okay. That y coordinate would be just the square root of 20. Let me do the y coordinate, square root, of course. Alrighty, folks. I hope you enjoyed that. I liked it. I like to generalize problems. So let me know what you thought.